Hello everyone, welcome back to the Next Level FAANG YouTube channel. Today we'll be solving another very interesting problem, which is number of islands problem. This is a very popular graph problem and it has been asked in various companies as well, like Google and Microsoft. So let's get right into it. So we have been given an M cross n 2D binary grid, which represents a map of ones, which is basically the land, and zeros, which is water, and we have to return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water, which means we have water in all four directions outside the grid as well. Like these directions, everything is covered with water. So, in simple terms, that every set of connected ones will turn out to be a single island. Now, what does connection mean here? Is basically when we look at this one, vertically down direction it is connected to this one, and then this one is also connected to the previous one in vertically down direction. And then looking at the same in the same way horizontally as well, we found another one is connected to this one. And in the similar manner, if we look at the entire grid, we find this one island which is largely connected to each other. So the output will be one because this is one connected piece of land surrounded by water, and rest here only we only have water and no land. So the output here will be one. So the naive approach which comes to my head is why can't we just, go through each element in the grid and look at every possible one? We can just track down each one present in this grid. But that is not enough because we also need to keep a track of the connected ones as well. Because this way we might end up like counting a single island maybe four times. Like in this case here, we have four ones together. So we need to look for a way where we don't do this. Like we don't count an island multiple times. So how can we do that? So let's start with this one. So we can see that in the horizontal direction, we have this one, which is connected to this one, the previous one, and this is also connected vertically to this one, which is further connected to this one. So all these four ones are connected. So when we are visiting this one, why don't we just make sure that we know that we have already visited this one and then start exploring the neighborhood. Neighborhood is basically the horizontal and vertically available ones. So in this way, if we keep on visiting and then marking them visited as well, so this way we can know that this entire is a single island and we don't need to count it like four times now. Similarly, when we move here, we'll be visiting this one. We'll look around. We'll only find water. So no other neighbors are needed to be visited. So this particular one will also be added to the visited set. Let's say if we use a visited set, or we can just do one thing that whenever we are visiting a particular one, we can just change it to zero. This way, it makes it a it makes it water, and we don't want to count water in island for sure. So this way, in a similar manner, we can do it for this island as well. So this way, we can conclude that this particular grid has four, sorry, not four, three islands. And so how we can actually code this solution now? So we can visualize this as graph. We can take one, which is the starting point, and once we are done visiting one, we'll convert it to zero, and then we can visit the neighbor. Like we can use a breadth first search, which is a graph traversal algorithm. Like in this layer, we can find these two uh, neighbors as well. And moving on, we'll find another one here. And in the next, we won't find anyone. So in this way, we have all the ones visited, and this will be added. The island counter will be updated. And accordingly, we'll also be able to track these ones and we'll count them as a single island themselves. So this is the approach I can think of at the moment. And the time complexity of this approach will come up to be, time complexity will be M is which is the rows into N because we are visiting and looking which at each element of the grid. So time complexity will be equal to M into N, and the space complexity in the best case, in the best case will be go of minimum of M comma N. For the Q we'll be using for BFS. And in the worst case, if this entire grid is a connected piece of land, let's say. So in the worst case, So in the worst case, it will become big O of m cross n only, which will be equal to the size of the grid. So now let's get to the code. So this is the code to the discussed approach. So in this particular solution, we have taken a directions array, which is a 2D array, which will help us to move in the grid up, down, left, and right. We'll simply be adding these values to the iterator RNC, and we'll move in all possible directions and keep a track of all the connecting land, which is basically the neighboring ones. And this is the function which is taking the grid, which is our main function. And then we have the rows where we're keeping the number of rows in the grid, false, where we're keeping the number of columns in the grid and taking the islands as the counter for the number of islands. Then we are traversing the grid and finding one. And whenever we find one, we'll perform BFS and to mark all the collected land, and then we'll increment the counter of for islands, and then we'll return the value of islands. So how we are performing BFS? Let's see. So in BFS, we are taking in the grid, the iterators RNC. We have the queue initialized here for the BFS. We are marking the first element. We are starting the DFBFS with as visited, and then we are pushing the current element in the grid as well, in the queue as well, and we're also processing all the nodes in the queue. So while queue is not empty, we take the front element from the queue and we explore all the four possible directions using our directions 2D array, which I just showed you. And once we get a new row and new column iterators, we simply check if new position is within the bounds. First of all, NR and NC should be greater than 0. And if they are in bounds, which means that the size is equal to the row, is in bounds with the number of rows and number of columns we have, and the visited element is also equal to 1, then we push it further in the queue to add new land to queue for further exploration, and we mark it as visited as well. So this way we keep a track of all the connected islands, and we do not count a connected island multiple times and add it to the islands variable we have here, which we are returning as the answer. So this is the entire approach to the problem, number of islands. You can also try this problem using DFS, which is another graph traversal algorithm. And also like, share, and subscribe. And do comment any new questions you want us to solve further in the channel. Thank you so much.